Okay, welcome all of you. This is the week 8 webinar, and it's quite an important one, as we'll see. Let me share my desktop so that you can see what's going to happen today. All right, so the plan today is the following. We'll start out as always with any questions you might have. And then after that, we're going to continue with hypothesis testing and actually confidence intervals too. Once you've learned about hypothesis tests and confidence intervals, then you could just do them. And you do them for things that we haven't done them for before, but the ideas are the same. That's the nice thing, is that if you understood chapters 8 and 9, then chapter 10, there's not that much new to do. The bad news is that chapters 8 and 9 are hard. Okay. And in fact, what I've been doing most of the day is grading your discussion posts. And I definitely know a lot of you need some work, and you definitely want to work on hypothesis testing definitely before the exam, because it is a pretty big part of the exam. So it is important that you get that verbiage, all the wording in is very important. And I'll mention it today as a review, but also as new, because that's the good thing, is now we're spending the rest of the quarter pretty much doing the stuff we've already done with variations. And the variations that we're doing today is we're moving from one sample to 2 samples. So we're going to be doing comparison studies. And it turns out, I would say that comparison studies probably happen 10 times more often than single sample studies in the real world. So today's a really important day in terms of using it. So I'll start out by talking about the difference between proportions. So if you have 2 different proportions and you want to say, which one's bigger, then we can talk about it. Or if you want to say how much bigger is one, then we could talk about it. Let's see if I can ask you in just a second. When I say which one is bigger versus how much bigger is one, they're completely different questions. When I say which one is bigger, what kind of statistical analyses do we do? Compare to, but how much bigger is also comparing to. So what kind of statistical analysis do we do? What's the name, the big name, statistics name? And it's either last week or the week before. Because it's very important to get down for the test, by the way. Significantly, that's one word that might come up in it, but what do we call the whole topic? The idea is, I'm not hearing it. I'm hoping y'all know. So if I ask you which is bigger, that's a hypothesis test. Okay, that's a hypothesis test. Okay, whereas if I ask how much bigger is this one than the other one, then what is that? And I will promise you, this is going to come up in a big way in the final exam. So you definitely need to know this. So if I ask you how much bigger is something, then what am I talking about? Proportion sometimes, but not necessarily. So which is bigger is a hypothesis test. How much bigger is this one is a, don't see y'all jumping in. All right, I'll say it then. It's a confidence interval. Really important you know that. Confidence intervals tell you how much bigger one is than the other, whereas hypothesis tests tell you this one is bigger or smaller or different. So very important. The verbiage is so important in this class, or it's going to knock you out on the final exam. Okay, and this coming exam too. So we'll start out with proportions, and that's when the survey question is a yes, no question. But often it's a survey questions instead of question because we're going to be doing two different proportions. And then we'll talk about independent means. So that's when the survey question is quantitative. Okay, and typically there's one survey question in two groups. Okay, and then we'll talk about dependent means, and that's also quantitative, but that's often two survey questions in one group. So we'll see what that means. Then what we'll do is I'll talk about the second exam, which is coming up very soon. And there's three choices, either Thursday, Saturday, or Sunday, you can take it. And I've written all three. They're all ready to go. All they have to do is open up for you, and then you take it on the time that you take it. Okay, so that's the plan today. Are there any questions about anything so far? Okay, so I'm going to do a difference between two proportions study. And this probably will be the very last time I do this particular special topic. What's the big thing going on this week? And if you don't know, and I'm not talking about in this class. Yeah, if you don't know, then you're asleep or something, and you've been asleep for a long time. So the election and the last day to vote is? Yeah, which happens to be, by the way, tomorrow. Okay, if you haven't voted 24 hours from now, you didn't vote. Okay, maybe 26. I'm not sure when everything closes, but something like that. So again, so I figured I'd do an election one. Elections are usually have proportions involved because it's almost always a yes or no question. Okay, sometimes you have three choices or multiple choices of people. Well, usually it's two, even when it's people. And I won't get involved. The interesting thing, I'm watching a lecture on political science right now, just a Duke University class. And he was talking about why it's two. And it was really cool. I won't get involved in it, but it's really cool. And when you only have two choices, that's yes or no also. So in particular, presidency is yes or no. Okay. I know you can choose. There's a Green Party or Libertarian or write-in, but it's Biden or Trump. None of the others are going to win. That's just not going to happen. Okay. Statistically, not going to happen. Okay. And you can trust me on that, but I'm sure you understand too. So pretty much everything we do when it comes to a people election, it's a two people only choice. So what I want to do is I want to do an example. Okay. And the nice thing about the elections is that you can find it in the news. So let me pop up a news article. And this is, let me read the title. So California ballot measure to lift ban on affirmative action, widely opposed by surveyed voters. Okay. So this is an interesting one because what matters is really not are the yeses over 50%. And that sounds a little weird, but it's really, are the yeses more than the nos? Okay. I know you don't have you kind of don't have another choice, but you really do. What's the other choice between besides yes and no? Yeah, it's not really maybe or undecided. There's actually one other choice on the ballot. There's no maybe on the ballot. But there's another choice. Actually, the exact opposite of what you just said. Don't fill it in. Leave it blank. So you can leave it blank, and then you're undecided or don't want to vote, and you can do that. You're allowed to not vote. Okay. I don't recommend it. I recommend researching and really making a decision which is better, yes or no, on everything. But you don't have to vote yet. So when they do a survey, you typically have that. So what we want to do is we want to find out, are the yes percents greater than the no percents? Because that's what really matters. It doesn't matter. You don't have to get 50% of people wanting it for it to pass. You have to get 50% of the people voting to pass. Does that make some sense? And a lot of people don't vote. So in particular, let me go back to the webinar. I mean, to this guy. We're going to have a H naught, and you're used to this. And now we're going to have a different type of H naught and H1 than we had last week, but only a little bit different. And that is H naught is, well, first thing is it's still proportions. But now it's a proportion of yeses versus the proportions of nos. And H naught is the yeses equal the nos as proportions. So I'm going to call that P sub Y. That means the proportion of yeses is equal to P sub N. And those are the nos. Any questions at all on H naught? Okay, what we always had before, or last week we had, is we'd have P equals a number. But now that we're talking about comparing proportions, different proportions, you can actually talk about different P's being equal to each other instead of a P being a number. Okay, and then we're going to have an H1. And I'm going to hypothesize that this is going to lose. Okay, I don't know if it's true or not. Oops, H1. If it loses, what is the inequality now? Yeah, it's a less than. So P sub Y now is going to be less than P sub X. N. Any questions on H naught and H1? Okay, I'm not going to go through every detail because we did that last week. But the next step in reality is you look at a type 1 and type 2 error. And then based on the type 1 and 2 errors, you decide what the level of significance is. But this is definitely political science. And what did I tell you the level of significance always is in political science? What number? If you're doing politics? Yeah, 5%. So I'm going to let the level of significance be 5% because that's standard. I'll call it 0.05. Any questions on that? Okay, then we look at the data. So let's go grab the data. So now I have to go back to the article. And what we see from the article is a survey of Public Policy Institute of California of 1,168. Let me write that down. 1168. What letter is 1168, by the way? Very important you know the letters to put in. What letter do we use for that number? Yeah, that's N. And in this case, with this particular example, so I'm going to call it N1 and also N2, or NY and NN. So basically, you can sometimes have surveys that are yes/no surveys where you're comparing two different groups and the groups don't have to be the same size. So for example, I couldn't find an article on this, so I wasn't able to give it to you as the example today. But let's suppose we wanted to find out, is there a difference between men and women on how they feel about Prop 16? Okay, so you might survey, say, 500 men and 600 women. Is that okay to not survey the same number? What do you think? Or do you think that's a disaster and then you can't do any statistics if you surveyed 500 men and 600 women to compare? So what do you think? Okay, the answer is it's fine. You don't have to survey the same number. What you do have to make sure is that NP and NQ for both groups is greater than 5. So that's still true. You still have to have NP and NQ greater than 5. But you don't have to have the same sample size. No problem. You could have 500 men and 20,000 women, and that's not an issue because you're not putting them together. This is not project one. Okay, so it's not a problem to have different sample sizes. Okay, this is not for stratified sampling. This is comparison study. Project one was a lot of you did stratified sampling. This isn't stratified. This is comparison sampling, comparison study, very different. Okay, any questions so far? Okay, note that we have 47%. Let's see, 31% are yes. And 47% are no. And I'm going to just do a very simple little thing here. Let's see. And I'm going to say, what is 31% of 1168? And 362. And what is 47% of 1168? Is 549. Any questions so far? Okay, so next, what I'm going to do is I'm going to go to my calculator. Which calculator do you think it is? What number? It's not 16 because 16 is a proportion. That's a hint. So 16 was last week. Yeah, this one's 19. Two proportions now. We're comparing different proportions. So I'm going to click two proportions. And first sample, the sample size was 1168. Second sample size coincidentally was also 1168. The number of successes for the first sample was 362. The number of successes for the second sample was 549. So hopefully this doesn't look too hard. And it was a lesson. We already wrote that down. Confidence level, we chose, let's choose 0.95 because even though we're doing a hypothesis test, I can talk about the confidence level also. Then what we do is we hit calculate. And what do we get? Well, the test statistic is negative 7.932. I want to ask you, is the p-value 1.0547 about? What do you think? So is the p-value about 1.0547 to 4 decimal places? Is that the p-value? Right. The p-value can never be bigger than 1. It's a probability. Probabilities aren't bigger than 1. You need to look at this part. Yeah, this will zap you on the exam, by the way, if that happens to you. Okay, because you'll get the exact wrong answer. Okay, exact opposite. So E negative 15, that means there are 14 zeros before this one. The p-value is about as close to 0 as it gets. Okay, what does that tell you when the p-value is about as close to 0 as it gets? One more guess, Kevin? Yeah, it's about this is as strongly significant as it gets. Remember, small p is significant, large p is not significant. Very important to remember that. Okay, so get that in your head, okay, or on your note card, whatever it takes, but you need to know this for the exam. Yeah, so small p, p less than the level of significance, that's small p's, then that means that you reject. So this might help you. Okay, picture yourself at a restaurant, okay? Or how about at home, because no one goes to restaurants anymore because it's dangerous. Okay? And remember, rejecting means that you got what you wanted, right? You're trying to show this is true. You're at the table for dinner, and you have your meal, and on the side dish are peas. Do you want them to be these giant, mushy, hairy peas, or do you want little guys as peas? What tastes good? Yeah, little guys. Little guys are good. So little guys mean that you get to reject the null hypothesis, and you get to say that you know, or you have evidence to support the claim. Whereas if you have really big P's, then your history, you just say, I don't know. This was a total waste of time. I don't have evidence to say anything. Do you see how that works? So maybe that'll help. And whatever works for you to learn it, but you got to learn it. Okay, so this is as small as it gets. So that means that we reject the null hypothesis. When do you accept the alternative hypothesis? When do you accept the null hypothesis? Does anyone remember what I said last week? In one word? When do you accept the null hypothesis? Never. If you ever accept the null hypothesis, you will lose points. You fail to reject, which is a fancy way of saying I know nothing. And that is never a happy thing, to know nothing. Yeah, so if the p-value is greater than level of significance, then you fail to reject, and you just say you don't have evidence to say anything. Okay, you can say I don't know in a fancy way. I have statistically insignificant evidence to support the claim. Do you see? That's another way of saying I am totally lost and ignorant, and I have learned nothing from this study. Whereas if you have a small p-value, then you say what I thought was true and I was trying to show was true, I have evidence for. Okay, I don't think good is necessarily the right word, because if sometimes you're seeing evidence if something kills somebody, and you don't want to kill anyone, but you need to study it to find out. So that could happen. Okay, so just let you know, the word good is a dangerous word. Any questions on this example so far? So that means there is statistically significant evidence, very strong statistically significant evidence. And I want to mention that you only use the word strong if you're less than 0.01. Okay, you wouldn't use the word strong if you're like 0.02. Then you just have statistically significant evidence. You're still good. You still got that statistically significant evidence, but if you use the word strong, that means you're tiny, and this one's as tiny as it gets. So here you can even use very strong. You can really emphasize it. So you have very strong statistically significant evidence that the yes vote percent for the whole California is smaller than the no vote percent for all of California. Okay. So what is the only, reason why this could go wrong at this point? And here's a hint. Think about the first week of class. It's really the only reason after looking at this p-value that the proposition can still pass. Do you remember what happened the first week, week 1? I know, it's been a long time. Okay, it could be a bias study. And if you have a bias study, you can't say anything. Okay, and honestly, I don't know how they did the survey exactly and all that. They always say they use some kind of random dialing, but I don't know for sure. So, I would not stake my life on this. I would stake my life on it if it was a truly random study. But truly random is impossible anyway. So the only reason why this could go wrong is at this point, when you have such a low p-value, is that you have a bias study. Okay. I want to look at the confidence interval and notice it goes from 20%, negative 20% to negative 12%. Now, when talking about the confidence interval, I think it's easier to go to positives than negatives. So if it's negative, that means that the proportion of yeses is less than the proportion of nos. If it's positive, then the proportion of yeses is more than the proportion of nos. So in particular, what we can say with 95% confidence, we can conclude that somewhere between 12% and 19% more voters are going to vote yes. Going to vote no than yes on this proposition. Okay, so this actually tells you what the range of, this tells you how much it's going to lose by, whereas the hypothesis test just tells you it's going to lose. Do you see the difference? Okay, given this is an unbiased study. Any questions on this example? Okay, I'm not typing everything out, but this is recorded. And one of the reasons is it takes a lot of time, and I want to get to the exam review. So it's faster if I could just say it. But please stop me if I go too fast and you have questions. And you are responsible for being able to write this out. Okay. And I also let you know, this is kind of interesting. If you go to the textbook, this is one of the few places in the textbook. If you go to the textbook that was written by Ilowsky, except the confidence interval between two proportions. That was not written by Ilowsky. Any guess on who wrote that part of the textbook? Yeah, I did. I did. It was missing. I got all these requests from all these people. And so I said, all right, I'll just write it. So then I wrote that part of the textbook. So there are a few pages, one more section I wrote a little bit. So I wrote that piece of the textbook to talk about confidence intervals for a difference. Okay, for each of the sections in this chapter. So if you recognize my way of wording, then you'll know why. Okay, any questions on this? All right, so let's get to the next type. So we just did the confidence interval and hypothesis test for the difference between population proportions. The next is when you have the difference between independent means. So first thing, I'm going to type a few things out here. Let me talk about independent. So when we're talking about independent means, there we go. So the first thing is it's got to be quantitative. So it's going to be one quantitative survey question. Asked to 2 different groups. And the goal is to compare. So I want to really emphasize this is very different than stratified sampling. The goal of stratified sampling is not to compare the groups. What's the goal of stratified sampling? I know it's been a while, but we talked about it. And next month, you're going to be asked possibly in the final. So what is the goal of stratified sampling? So if you stratify by gender with men and women, for example, the goal is not to compare men versus women. Yeah, it's to reduce bias. Okay. Whereas now our goal is to compare 2 groups. It's not about trying to reduce a bias on the groups. It's comparing the groups. So typical things you might compare are men versus women. Okay. Other things you might compare would be a control versus a treatment, like a placebo versus a treatment group in medicine. So you might want to say, well, you're going to give a bunch of people a placebo. You're going to give a bunch of people the medicine that you hope works, the test medicine, and see which one is going to have the fastest healing process. Any questions on that idea? Okay, and those are going to be independent groups that you're comparing with. Any questions so far? Okay, what I thought I'd do, because you requested it, be careful what you ask for because you're going to get it sometimes. I'll just do it this way. Let's do a homework problem. So let me get your homework. And while I'm here, so it's a kill 2 birds with 1 stone thing. Let me show you some dates, very important dates. Okay, first thing, Thursday, first chance, due by 8 p.m., which means it starts at 6 p.m. That's your first chance to take your exam. Saturday, second chance to take your exam. Okay, and that's 8 a.m. Sunday, third chance to take your exam, and that's 1 p.m. Okay, if you have special accommodations, you need to let me know what day you're taking it so I can give you that special accommodation, because that has to be done by me by hand. Okay, so if there's any kind of special accommodation that might have happened if you did it somewhat differently than everyone else, then you need to send me an email to let me know when you're taking the exam. Got it? Okay, and then I will make sure that the accommodations happen, but if I don't know, I can't do the accommodations. So you just have to know I'm taking it on Thursday. Remember, I get 4 hours, or remember I'm on Zoom, or whatever it might be. Okay, so that's just a note. Okay, another thing is there is a secret word quiz. I'll be doing that in 20 minutes or so. So I'll be giving you the secret word. Notice something that isn't here this week? Yeah, I decided not to do a discussion post because this is exam week and projects coming up not too long from now either. So there is no discussion post requirement. You're always welcome to just post on the Q&A if you have questions. Okay, or the project discussion if you have that questions. But there's no discussion assignments. So I've lightened up on that because you got exam 2, which is a heavy exam. Okay, so that's just a note. But there is a chapter 10 hypothesis test for difference homework assignments, assignment of the chapter. And I'm going to use teacher preview because it's just a little faster for me to pop through. So let me pop one up. That's a good example one. Yeah, I'll show you that in a bit too. Let me get through this first though. Okay, so let's look at question 3. Okay, question 3 is the following. Do political science classes require less writing than history classes? Okay. Okay, by the way, I'll let you know I made up this question. I have no idea, but you could do a study. Okay, the 52 randomly selected political science classes assigned an average of 13.2 pages of essay writing for the course. Okay, the standard deviation for these 52 classes was 3.1 pages. The 46 randomly selected history classes assigned an average of 13.9 pages of essay writing for the course. The standard deviation for these 46 classes was 4 pages. What can you conclude at the 0.10 level of significance? Any questions on the question? Okay, so the first thing is note that the survey question is you're going to ask this political science teacher or this history teacher. What are you going to ask the teacher? Or this professor? What's the survey question going to be? Probably not average, because these are assigned, but just how many pages do you assign in your class? Okay, and the answer is going to be a number. Oh, I assign 15 pages. Do you see how that works? So that's important. This is a quantitative survey question. And notice that there are 2 groups. There's the group of political science professors and the group of history professors. Do you see that? So we have 2 groups, quantitative survey question, and we're comparing the 2 groups. So now we have a lot of choices. T-test for the difference between 2 dependent population means. A Z-test for a population proportion. A Z-test for the difference between 2 population proportions. A T-test for a population mean, or a T-test for the difference between 2 independent population means. Which one of these is it? Number 1, not quite. Good try. Number 3, not quite. It's not a proportion. It's not a yes/no question. It's number 5. These are independent population means, right? Quantitative survey question, and it's 2 groups. Any questions on that so far? Okay, now let's do the null alternative hypotheses, H naught. Is it a mu or a p? Yeah, this is a mu. What inequality or equality is it? Equal, greater than, not equal to, or less than. This one's equal. H1's always equal. And mu or p? Yeah, this is mu. Okay. And then H1. Okay. The good news is once you got H naught, H1 is going to have the same mu1 and mu2. So I'll just tell you. But is it equal, greater than, not equal to, or less than? And we might want to go back and read it again. And there's one key word here that will tell you which one it is. Yeah, it's less than. The keyword's less than. So it's not a trick question, but you have to look for that little tiny word. Okay. The test statistic. Is it Z or T? Yeah, this one's T because we don't know the population standard deviations, which you never will with quantitative data. Okay, so it's T, and now we need to get our answer. So this is where we have to look at all the numbers. So let's get our numbers. We have 52. That's N1. We have 13.2. That's going to be X1 bar. Then we have standard deviation. That's S1. And that was, just lost it. The 52% average that. Standard deviation for these 52 classes is 3.1. Then we have N2, and N2 was 46. Then we have X2 bar. X2 bar was 13.9. And then we have S2. And S2 is 4. And alpha is 0.01. 0.10, I mean. All right, let's go back to the calculator. What number? Yeah, this one's 18. 2 independent samples with statistics. So our first sample size was 52. Our second sample size was 46. Our X1 bar, 13.2. Our X2 bar was 13.9. And then we have our sample standard deviation. S1 was 3.1. And then S2 was 4. Okay, any questions so far? Less than is what we had. And then our confidence level. We're not asked for it, but just for fun, how about 0.95s to show you that you can actually get a confidence interval? And hit calculate. There's our test statistic. T equals 0.95914. And then we have our p-value is 0.170112. How about? Have I gone too fast? Is everyone following what I just did? Any questions? Okay, so now what I want to do is let's take a look at the question again. That was one of these guys. Is it that one? There we go. So our test statistic was 0.95914. Our p-value 0.17012. Okay. Now is the p-value less than or equal to, or is it greater than alpha? Yeah, this one's greater than. So reject, fail to reject, or accept the null hypothesis. Yeah, fail to reject. By the way, when would you choose accept? What would it take for you to choose accept? Yeah, it would probably take a lot of money, actually, or a lot of booze. But basically, don't do it ever. We fail to reject in this case. You either fail to reject the null hypothesis or you reject the null hypothesis. You do not accept the null hypothesis. All right, which of the four is the conclusion? I'll let you read through them. So 1, 2, 3, or 4. Yep, this one's number 2. There's statistically insignificant evidence. So there is insufficient evidence to conclude that the population mean number of pages of writing that political science classes require is less than the population mean number of pages of writing that history classes require. I want to mention something that's very important for your project, for project 2. These two words, population mean, are going to be many, many, many places in your project. Okay, if they're not, do you know what's going to happen? Yeah, or even better, you're going to send me your draft and I'm going to give you all kinds of comments about how come you didn't say the population mean. And I just noticed that I graded the discussion post today, and a lot of you did not put the word population in when you did your analysis. And you need to have that. So that's important, even though, by the way, we're talking about what we're doing. This chapter is not on the exam, on the second exam, but last week's was, and it's not that much different. So this should like re-emphasize that you need the word population whenever you're doing a hypothesis test. Scroll up. Tell me when to stop. There's a lot of scrolling here. Okay. Oh yeah, I don't think I got to that. I think I went too far. So the results are statistically, or is this another question? No, this is a different question. You really want me to stop here? This isn't the one we're talking about. This is a whole different question. This was question 2. We're working on question 3. Yeah, we're on question 3. I mean, you're eventually going to have to do the others, but I did like one like that already. Okay, so anyway, that's what these look like. Any questions about a hypothesis test for the difference between independent means. All right, I think I want to do a hypothesis test for dependent means. And let's see if you're interested in anything about each other that you want to compare. And here's the thing. It needs to be things that you can compare by subtracting. So it does not make any sense at all to compare your age versus your height, because if you're 30 years old and you are 5'7", you can't take 30 minus 5'7" and get a number. It makes no sense at all. So is there anything that you think you might compare that you might be interested about each other, just for fun? I'll take the first request and we'll do an example. So it's two different questions that you're going to compare. Okay, age and education. Again, I have a PhD and I'm 54 years old. What is 54 minus PhD? See, that doesn't work. It has to be two things you can subtract. All right. Well, you got to have two things. Salary, but no, salary is one thing. Salary and age? Come on. 90,000 minus 54? That makes no sense. So two things that make sense. Shoes and sweatshirts. That could make it. Okay, we'll do that one. That's the first one that works. So I have two questions. Okay, and the questions are, number one, and let me put it in here. How many pairs, I'm going to do pairs of shoes, do you own? And number two is how many sweatshirts do you own? So my guess is that's what you're asking, right? And that you can subtract. Okay, so let me ask you again, Genevieve, because you're the one that asked. What do you think is true? Do you think people have more shoes? Do you think people have more sweatshirts? Or do you think that, or maybe you just want to know if there's a difference? You think more shoes. So now let's write down our H1. So we're going to let a special letter, and that is D for difference. And D is going to be shoes minus sweatshirts. And if we look at it that way, then we can write H naught and H1 in a very different way. We can write H naught as mu sub D equals 0. Because if the shoes and sweatshirts are the same, then you get 0 when you subtract. Any questions on that? H1 is what? Mu sub D. Let me write that out. And what's going to be the symbol? How do you configure the if? I'm not sure what you mean by that so far. So I don't know what that question means. How do you configure the if? So you have to ask a little, how do you decide on the scenario, you mean? It's whatever you're interested in learning about. That's why I asked you, what are you interested? Genevieve was interested in and she thought that people might have more shoes than sweatshirts. Maybe she's got a clothing store and she wants to find out what she wants to put in the front of the store so everyone gets excited when they see it in the window. Do you see what I mean? And if they have more shoes, maybe they'll put shoes in the front of the store. Do you see that? That would be a reason why you'd care. Okay, so that could be an example. Okay, so what symbol comes after mu sub d for H1? Yeah, so what like, is it greater than, is it less? That's whatever you think is true, whatever you're interested in trying to show is true. And that's true always with hypothesis testing. Now, on a test and stuff, there'll be a paragraph and you have to look for the key words. But in the real world, you're going to have to decide on it. And the real world means your project, by the way. Okay, so mu sub d, what comes next? What inequality? What symbol? Double up, happy thing. Greater than, there we go. Greater than 0. Okay, in our class, we're always going to have a 0 on the right-hand side. There are very occasional instances where it could be not 0. So let me give you an example, not this example, but let's suppose you're a principal at elementary school and you want to show that your students are learning more than one grade level in the second grade because you have an awesome teacher. So then you would have mu sub d equals 1 because you're going to do a before test, the first day of class and the last day of class. And if you want to show that it's more than one grade level achieved by the end of the year. Do you see that on standardized testing? And you would have mu sub d is equal to 1 versus mu sub d greater than 1. So there are a few times, but not very many, where you won't see a 0. Almost every case you see a 0. Any questions on this? Okay, what I want to show you next is a spreadsheet. And there is a reason why I want to show you the spreadsheet. I actually mentioned it. I think I have to move my Zoom thing just a second. There we go. Let's try again. Let me move it. There we go. And let's move that. There we go. Let me go to my spreadsheet program. Sorry, it's always hard with Zoom to get things out of the way. Drive, there it is. And this is the same spreadsheet we did last for the project 1. But the big difference between this spreadsheet and between project 1 and project 2 is the following. See if I can get it. It's really hard with Zoom to get things placed right. Just messing with me. Sorry about this. Let me maximize it. That might do it. There we go. And the big difference is you were using the first tab, 1 Veristats, for project 1. Project 2, we're using the second tab because now we're in 2 variable. And what I'm going to do is I'm going to first highlight all these numbers and hit the backspace to just erase them. Next, I need to get the data. How am I going to get the data? I'm going to ask you. So what I want you to do is tell me how many shoes you own and how many sweatshirts you own. So in the same line. Otherwise, it's going to be really confusing. There we go. We got a 12-9. Keep going. I want all you need. Yeah, everyone needs to answer. I'm not going to have a big enough sample size. So how many shoes and how many sweatshirts? So 5, 4. $15, $14. 6, 3. Whoa, 65, 40. You must have a big closet. Okay, 7, 5. Anyone else? See who we don't have yet. Again, if it's not in the same line, I can't type it in because it's already off my screen. Okay, no one else? Okay. So now what you have to be able to do is move your eyeball to the right place. Is this dependent? Is this independent or is this dependent? One more guess. This is dependent. So independent means there's two groups answering the same question. Dependent is when you have one group answering two questions. Okay. It could also be paired things answering one question. So it could be husband and wife, for example, answering the same survey question. And that would also be dependent. So if you want to find out who does more chores in the house, the husband or the wife, and you asked a bunch of husbands and wives, paired people, then that would be dependent. Okay. It could also be something like, is there more snow in the north side of Tahoe or the south side of Tahoe? And you look at 100 different days. So it's not people answering the question, but it's like a day answering two questions. Do you see how that works? You're going to ask December 30th, how much did you drop on, how much snow, hey, December 30th, how much did you drop on the North Shore? And how much did you drop on the South Shore? So it doesn't have to be a person, but there has to be some link between the answer for the first question and the second question, if there's two questions. Any questions on that? Okay, so then just let you know in your project, you must, or you're going to lose a lot of points. You must copy this and paste what I just did into your project. Now you can choose dependent or you can choose independent. That's totally up to you, but it needs to be quantitative because otherwise you'd have to have more than 1,000 in your study and that's never fun. So just to let you know is that's what you're going to be doing in your project. The project is really on chapter 10. Okay, so that's just a note, and it must be copied and pasted. It is not hard to copy and paste, but it's going to be hard if you don't because you're going to cry when you see all the points I take off. Got it? Okay, so that's just a big note. Any questions on dependent data? Okay, what's the p-value for our particular example? And what I did is I wrote down, because I programmed this, p-value two-tailed, p-value right-tailed, or p-value left-tailed. Which is it? Okay, so we may need to go back to our hypothesis. And we have mu d is greater than 0, and that makes it a right tail. So the p-value is 0.09. Okay, so by the way, when we have such a small sample size, our sample size is tiny here. Our sample size, our n was, where is it in here somewhere? I have too much Zoom window stuff going on to be able to see everything. Our n was 6. So with an n of 6, you're not going to get a low p-value. Okay, that's a ridiculously low sample size, by the way. So even though it seemed like there was a big difference in the answers, the sample size is way too small to get any kind of significance. So the p-value here for dependent difference for the right tail was 0.09. So if you use 0.05, for example, then there would be statistically insignificant evidence to make the conclusion that the population mean number of shoes that students have is greater than the population mean number of sweatshirts that students have. Any questions on that example? Okay, so now that we've got, let me move more Zoom stuff out of the way. Okay, that's pretty much, if you look at what I have to say, that's chapter 10. And again, I got to go through everything fast because we just have the one day. And I do want to get to the exam 1 review. But before I do that, I have a secret word for you. And the secret word of the day, of the week, is compare. Okay, and it's compare because what this particular chapter is all about is comparing two proportions or comparing two means. So the secret word is compare. Let me do the following. It's too small. That's good. Okay, so the next thing to talk about is the exam. So first thing, I showed you already the 3 times that you are allowed to take the exam. You have 2 hours to take the exam. The rules of the exam are exactly the same as the rules for exam 1. So what do you bring with you? Yeah, you could have a 3x5 note card. You can write front and back. Okay, and it's going to be different stuff. This is not a comprehensive exam. So I'm not going to ask you about stratified sampling, for example. That was exam 1. So you're going to have different stuff on the note card. Okay, it's too precious to use it for, use the old one and add more. So I recommend starting over with your note card. Okay, so the note card definitely is something you want to use. Okay, so that's a note card. You're allowed to bring a blank piece of paper. You just show it to the screen if you want to write some stuff, but be careful about writing a lot of stuff on the blank piece of paper because I don't see it. So you don't get credit for anything you write. So most of your work should be done on the computer. Okay. Unfortunately, I wish between the exam 1 and exam 2, we had a vaccine and I could do this on campus, but I'm not allowed. So we still have to do it on computer and you can't come and take the test on campus. So maybe next quarter, I don't know, I doubt it, maybe spring. But right now it has to be done purely on computer. There's just no way around it. So sorry, but I'm not the one that made COVID happen. That I promise. Okay. So we have to do it that way. So the exam is with Proctorio and it's going to be the same thing. You got to have a webcam. And if anything went wrong last time, hopefully you learned how to fix it. So this time you don't get that stress. Okay. The exam is the same amount of time as before, 2 hours. And then it gets shut off. So make sure that you get the exam done on time. Question number 1 is exactly the same question as question number 1 on your first exam. And it's the only one that's exactly the same. Okay. And if you can't answer question 1, I give you a 0 on the entire exam. Okay. Because either it means that you forgot your name and then you deserve a 0 because you should know your name, or it means that you want to cheat and then you deserve a 0 also. And that is you agree not to communicate with any adult and not use any other devices or materials for this exam that have not already been expressly allowed by your instructor. And I just talked about what you're allowed. And remember the definition of adult? Who remembers in our class? I know it's been a few weeks, but not that many. What's my definition of an adult? And it's the historical definition, not the modern definition. Yeah. Actually, adult is post-pubescent, child is pre-pubescent. But you got the right idea. Yeah. So if you have a child and you need to change its diapers, you change its diaper. You know what I mean? Or whatever, if you have a baby. But if you have a teenage kid, just tell that kid, don't bother me these 2 hours. Got it? Okay. So that's the plan. Although some of the kids are back in school. I don't know if any of you have kids, but I know that they are in school twice a week, at least up here. I don't know about other places, though. Okay. Very similar to the last exam. Problems 2 through 7 are true false questions. Do you remember you had that in the last exam? Okay. And very simple. You do true or false, but you got to be thinking about it. Those are idea questions. Okay, so let me go through the next one. Question number 8 gives you a paragraph. Just a second. I've got the hiccups. So it gives you a paragraph. And then it says, state the null and alternative hypotheses. Okay. And then it is actually, I think the numbering is wrong here. Number 1 is state. Let me do 1. I wonder if I can change it. Nope. So that'll be number 2. Sorry if it takes a moment. Whoa, 2. And then 3 will be write your conclusion in the context of the study. What's the first word in number 3 that you need to write? The first word for number 3. What's the very first word? Definitely not if. No one remembers? First word for number 3 is there. There. It was if I remember right, it was a secret word from last week. Okay, it was an important word. Okay, so very important to know that, to know what to write, because that'll get you started. Okay, was the assumption of normality necessary? Explain numerically. Okay, there are really two types of problems. What are the 2 types of problems when it talks about normality? Two kinds of studies that are very different when it comes to normality assumption. Any of you remember? Don't see y'all jumping in. Okay, there's proportions and there's means. Very important that you know this. With proportions, then what do you need? What do you need to not have to have a normality assumption or issue with normalities? Numerically, I'm looking for a special number. I don't see y'all jumping in. Remember, NP and NQ have to be bigger than 5. Okay. With means, you have to have n greater than 30. Any questions on that? Okay. Problem 5, based on your answer from part 3, right? Either a type 1 or type 2 error is of concern. State which one and discuss the repercussions of this error. Remember what the word repercussion means. I think mean bigger than is the last one you're asking. So if it's a quantitative question, then you have to be bigger than 30. That was a big deal before. We talked about that in central limit theorem. But what does the word repercussion mean? And remember, we did it last week. All right, I'll tell you if you don't. It means the damage that's done. If it's a repercussion of error, it's a damage. Who gets hurt? And how does that person or thing get hurt? Okay, the consequences. Okay, very important that you know this. Okay, number 9. Number 9 starts out similar. It's got a paragraph, state the null alternative hypotheses. Number 2 is write down the test you're using and calculate the test statistic and p-value. Number 3 is use a complete sentence to state your result using the something in the context of the question, which I'm not telling you that sometimes I have to leave some things blank. Okay. What's the first word on number 3? What's the first word? It's not that long to type. Not if. There. Okay. And then number 4 is a level of significance. 0.05 represents a probability. Use a complete sentence to interpret this probability in the context of this of the study. What's the first word for number 4? Because again, the first word helps you get started. So what's the first word for number 4? Yeah, that's the if. Okay, so let me move on. Number 5 is a p-value represents a probability. Use a complete sentence to interpret the probability in the context of the study. Just let you know, number 4 and 5 start the same way. The first phrase is the same. Okay, question number 10. Question number 10 is a sample size question. Okay, you're going to have to find the sample size necessary. Question number 11 is a confidence interval question. So you're going to have to find a confidence interval. You're going to have to interpret the confidence interval. And you may have to interpret the confidence level. And you may have to decide whether the sample size is large enough. Okay. And I'm going to skip 12 for a minute and just tell you number 13, same comments that I just said. Number 12 is a central limit theorem question. It has different parts, and you need to know the central limit theorem for means. You need the central limit theorem for proportions and the central limit theorem for sums. Now, it's been a while, so I want to remind you a few things. If I ask you for the distribution, the sampling distribution, what does that look like? Do you remember? What are some of the symbols you write down? And I'm not even going to say if. When I ask you, you're going to have to state what the sampling distribution is. And what symbols do you write? If I ask you for the distribution. There's one symbol that's on all of these. It's on your keyboard. And it's not a letter. That should help. Do you remember? I don't see y'all jumping in. Tilde. So that might give you a reminder of what sampling distribution is. We went over these. If you don't remember what I'm talking about, what should you do? Yeah, study and go back to that webinar. Go look at the book. Okay, again, it's been a while since you looked at this stuff. Don't just assume that you knew it then, so you're still going to remember it. Make sure that I like the word practice better than study. Make sure you practice. Okay, you should be able to do a few things. One is state the sampling distribution. The other is use the central limit theorem and use the normal distribution calculator and come up with the answer. And a third is know whether the sample size is big enough. Did you need to make the assumption of normality or not? So those are all important. Okay, just a note. Okay, and by the way, you must use the calculator that's on the computer. Okay, I am very harsh with credit if it's clear that you looked at something else that you're not allowed to look at. So if you said you looked at a table, I am going to zap you with points. Okay, I'm going to be mean to you on every problem. Okay, just let you know that because that means you cheated. Okay, so if you do it in a different way that you can't do with the calculator that's that's on the program, that means that you're cheating. And the way I handle cheaters is, boy, am I harsh on partial credit. Okay, so this is note, don't cheat. And I can tell. I can tell with Proctorio by watching you, and I can tell by your answers. Okay, I've been teaching a long time. So just let you know that it'll go badly for you. And I don't even say a word. I just give you really low scores. Okay, and it's obvious. Okay, if you're using something that is not allowed, and I know all the tools, so I know what you're using. Just let you know that. Okay, and all you're allowed to use is the test, and the test has the embedded calculator. So that's just a big warning. And does it happen? Yes. And I'm quietly mean. Okay, but if you don't cheat, there's nothing to worry about. Okay, any questions at all? Any questions at all on the test? What to expect? And my guess is I'll probably grade it Sunday and Monday. It takes a long time to grade. And I also learned that I think you weren't able to read my comments on exam 1. So I'm going to try a different way of doing comments so you'll be able to read them. I spent many hours writing these comments, and now I think you can't even see them. So the next exam, you'll be able to see my comments. Okay, just to let you know. Any questions at all on what to expect? Okay, I want to remind you a few things. Okay, right now for the next few days, main focus is exam 1. Okay. If you're taking on Sunday, you could even do the last part. You could do chapter 10 after you take the test, or you could do it now, whatever. Is the midterm good source to study? The practice midterm? Yeah, so if we go back to, I think it was here. And I believe I posted it somewhere. So if I go to, just a minute. The modules. Yeah, I think there's a few places I put it. So there's a practice test, I believe. I think I put it in there somewhere, did I? Yeah, it might not be in the module, it might be in the syllabus. That's what I was looking. In this week's module, we're in this week's module right here. Hypothesis confidence intervals, student learning outcomes, full-length video, and PowerPoint. I think I didn't put it in here. Yeah, it's not in this week's module. I thought it was on the syllabus. So let me check the syllabus. Just let me do a few things. There's a few places I can check. No, I don't have a link. Maybe I should put a link. Let me give you a link now. I'm going to give you a few links just for fun. One that might scare you because I think it's something like 192 pages long. So don't get, terrified if when you see how many example problems there are. But that's a good question, is where are things that you can study with? Let me go. I have to move some stuff. There we go. No, a little more moving. You go to my drive. Too much Zoom stuff running around here. That one. Might take a minute because it's very long. And this gives more than just this example. It gives you lots of different things. So let me share it. Exam 2 on certain chapters. Yeah, it's everything we did since the last exam. So it's central limit theorem chapter, which was chapter 7, 8, and 9. It's those 3 chapters. Just a minute. Can view, copy link. All right, so that's in the chat box. So if you go to the chat box, you'll be able to go to what I just showed you. That was that guy. And again, this is very long and this has everything. So you can scroll down and find lots of example problems from everything we do. So it's not just these 3 chapters, but everything. So don't get too scared that it's like over like almost 200 pages. So that's just one place you can find stuff. Another one believe, just a second. I think it's that one. That one. Practice exams. And I wrote this a long time ago, but it still might help. So there's a link of some practice exams in the chat box also. Hopefully that helps you. Okay. And it's 7:30 right now. I think I'm going to stop the share and stop the recording.